In this video, we are going to talk about rotation of axes. So far we've talked about conics, and conics have a general form of ax squared plus cy squared plus dx plus ey plus f equal to 0. This is the type of conics that we've dealt with. So we know that this can be a circle, a parabola, hyperbola, ellipse, whatever. So we are going to generalize this by adding this b term. So we're going to have ax squared plus bxy plus cy squared plus dx plus ey plus f equal to 0. So you notice that we have this new xy term. And this xy term actually is the rotating of axes. So this is rotating of axes. So whenever we have an xy term, that's when we know we have to use some sort of rotation of axes. So let me give you an example of why is it that we rotate these axes. So, and the easiest example would be when we have xy is equal to 2. So let's solve for y. We can divide the x over, so we have y is equal to 2 over x. And we know that by the parent functions from pre-calculus that 1 over x has a vertical and a horizontal asymptote, and they kind of look like this. Whoops. My drawing skills are terrible. Oh my gosh. Okay, so we have this thing, and then we also have this thing. Okay, so that's basically what it looks like. Now, if you were to think of a new coordinate system, so let's say I were to rotate these axes. So this is going to be this is my x-axis and my y-axis. Let me write this maybe in black. So let's say this is my x-axis and this is my y-axis. And then the thing in blue is going to be my new x-axis, and we're going to call it x prime. And this one, we're going to call it y prime. Well, this is a new coordinate system that's kind of rotated, and I can tell you that this rotation is 45 degrees. So when I rotate this thing, so let's say this is my new axis, let me draw it so that you don't tilt your head. You can kind of see that you have these hyperbolas here. Okay, so this actually looks something that looks like this. And we know that this is just the equation of a hyperbola, but they're not slanted. This is my x prime plane and my y prime axis. So we want to basically convert this xy coordinate system to this x prime y prime, because it's going to make it much easier for us to solve. So what we're going to try to do is derive the equations that will allow us to rotate the axes. So what we're going to start off with is the following. So let's say we are given a point x comma y. So given this point, we can rotate the axes to get the point x prime, y prime. So we want to have some sort of relationship between x and y to x prime, y prime. So what we're going to do first, and what we're going to do is use polar coordinates, and you'll see why polar actually works really nice here. So let's say we start off with our x and y plane, and then we're going to have our x prime and y prime plane. So here's x prime and here's y prime, rotated at a particular angle. So we're going to look at this point, x prime, y prime. So I'm going to write it over here so that you can kind of see what exactly is going on. Here's x prime, here's y prime. Here is my point, x prime, y prime, some random point. And what we just did is that we're going to convert it to polar coordinate. And we're going to call this theta and call this r, because that's how we convert it to polar. So we can represent x prime in polar coordinates as our cosine theta, and y prime is going to be our sine theta. So that's how we can look at it. So this angle right here is theta. So now what I'm going to do is I'm going to try to have or look at this point in terms of x and y. So if you notice here, we have an additional angle. So this is rotated theta degrees or radians, and this is going to be a new angle, phi. Okay, so I'm going to try to express x in terms of this radius and this theta and this phi. So we have that x, this x value, so this particular point, which is actually in the x and the y plane, is going to be equal to r cosine theta plus phi. Because if you notice, this entire angle here is just theta plus phi, and I'm representing this x prime, or this x value, in terms of the x and y axis, and then you have the value r, so everything is the same. And we can also represent y as r sine theta plus phi. So we have two different types of equations. So we have this red one and we also have that blue one. So what we can do actually is take this x equals r cosine theta plus phi, and we can use the sum and difference formula of cosine, which is a trig identity. So this is going to be cosine theta cosine phi minus sine theta sine phi. So I can distribute the r. So r cosine theta cosine phi minus r sine theta sine phi. And what I'm going to get, or if you realize this, is that this thing looks very familiar because we have this x prime y prime. We have this r cosine theta. That's just equal to x prime. We have this r sine theta. That's just equal to y prime. And then everything else is just going to come down. Cosine phi minus y sine phi. So we actually have an equation that relates x with y, with the x prime and y prime. So x equals x prime cosine phi minus y prime sine phi. So this is going to be one relationship. Now let's look at the other one with the y prime, because we're going to do exactly the same thing. So, oops, what color? Okay, so we're going to have x is equal to r sine theta plus phi. We are going to use, again, the trig identity, r sine theta cosine phi plus sine phi cosine theta. So now what I'm going to do, I'm going to distribute this. This is going to be r sine theta cosine phi plus r sine phi cosine theta. And again, you can see that r sine theta is just going to be equal to, if you look over here, it's going to be y prime cosine phi. And here this r and this cosine theta is going to be the same thing. That's just x prime. So this is plus x prime sine phi. So now we have another equation that relates x prime and y prime with our y. So we have y prime, oops, not y prime, y is equal to, and let me switch them around so that I can have the x prime first. X prime sine phi plus y prime cosine phi. So we have these two equations, and this is going to be really helpful because now I can relate this with x prime and y prime with my regular x and y. And now all we just really need is this phi. And we'll talk about that phi in a little bit. So let's do an example using this previous problem that we had. So let's show that this is actually a hyperbola in the x prime y prime plane. So we're going to do the same thing. So we are going to rotate the coordinate axes 45 degrees to show that xy equals 2 is a hyperbola. So that's what we're going to do. So the first thing that we know, and we'll get to the y is at 45 degrees, so we'll get to that. So the first thing that we're going to use is use these equations. So we know that x is equal to x prime cosine phi minus y prime sine phi. And we know that y equals x prime sine phi minus y prime, plus y prime cosine phi. And we know what phi is. Phi in this case is 45 degrees. So this is going to be equal to x prime cosine of 45 degrees minus y prime cosine sine of 45 degrees. And cosine and sine of 45 degrees is just going to be square root of 2 over 2. But the way that I'm going to write it is the following way. X prime over square root of 2 minus y prime over square root of 2. So I'm going to leave the radical on the bottom, and you'll see why. You can leave it as square root of 2 over 2, but you'll see that this is a little bit easier to work with. So we're going to do the same thing here. X prime sine of 45 degrees plus y prime sine of 45 degrees. This is also going to give us x prime over square root of 2 plus y prime over square root of 2. Okay, so now that we have, I'm converting my x's and my y's to x prime, y prime. So now is the most tedious part. So we know that originally we had xy equal to 2. The part that we have to do now is plug this in. So we know what x is. X in this case is going to be x prime over square root of 2 minus y prime over square root of 2 times y, which is going to be x prime over square root of 2 plus y prime over square root of 2 is equal to 2. So now let's go ahead and FOIL all of this out. Now luckily this is going to be the middle term is going to cancel out because we have a minus and a plus. So what we're going to have is going to be x prime squared divided by 2 minus y prime squared divided by 2 is equal to 2. So FOILing all that out is going to give us this. So now all we got to do is just divide this by 2. So that we have the proper form. So it's x prime squared divided by 4 minus y prime squared divided by 4 is equal to 1. And if you notice, this is actually an equation of a hyperbola. So basically, all I have to do is graph this hyperbola 45 degrees rotated from the original. So what I'm going to do is I'm going to take this x and y coordinate system. I'm going to rotate this 45 degrees. So I'm going to do the best I can. So this is going to be rotated 45 degrees. So here I rotated 45 degrees. So now this is going to be x prime, this is going to be y prime. In the x direction, I'm doing the square root of 4, which is 2. So I'm moving 2 units this way. And in the the y direction, I'm also moving 2 units up and 2 units downward. Okay, and since in this case we can just draw my box if I wanted to help me out, and with my asymptotes, and what you can see is that the hyperbola actually is going to start here. So I'm just going to go this way, and it's going to go the other direction. Okay. So if you look at this, rotated 45 degrees, we have a hyperbola, which actually, if my drawing skills were better, looks exactly like the original that we had, which is this one. So this is basically what rotation of the axis really does. It makes the problem look a little nicer, things that we know, a conic that we know, and then we can solve it or graph it using this method. Now, one of the things that we didn't really look at is what exactly is phi. How do I know it was 45 degrees? In the next video, I'm going to show you how to find that phi.